Hello, I welcome you all. The problem reads, if the mass of cylinder C is 40 kg, determine the mass of cylinder A in order to hold the assembly in the position shown or in equilibrium. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have the mass of cylinder C, 40 kg, and we've been asked to determine the mass of cylinder A so that the assembly is in equilibrium, or it remains the way it is in this position. So what we're going to do is we're going to draw the free body diagram, but before we do so, let's have a little discussion about this assembly. We have pulley B, okay, and we are assuming at pulley B there is no friction. So at pulley B there is no friction. And if this is the case, therefore we expect tension EB to be equal to tension BC. Okay, tension BC, right? So this is the tension BC here. This is tension BC, which is just basically the weight of this cylinder 40 kg. So let me write it down. So this is tension BC, which is just equal to 40 kg times the acceleration due to gravity, which is 9.8. This therefore gives us a 392.4 newtons. This one here is tension TEA. Okay, let's call this one here as tension ED. Then this one we already called it as tension EB. Okay, so if this is EB, we expect this also to be tension EB. Okay, right. Let's add more information. We're calling this first body as our free body diagram A, the other one free body diagram B. So on free body diagram A, we are going to have these components that we use later on. Vertical component of TEB. So this one is TEB sine 30. Then we expect another component in this direction, which is TEB cos 30. Okay, and this angle here is also 30 degrees. All right, so with this information, we are going to apply the equations of equilibrium so that we find what TA is. We already know, like we said, that TEB is equal to TBC, which is equal to 392.4 newtons. Summation of forces in the y direction. What do we have? We have TEB, right? TEB sine 30 minus TEA. Okay, we already know what TEB is, which is this one here, is 392. Replacing it in there, then we'll find that our TEA is going to be equal to 392.4 sine 30, which is eventually equal to a 196.2 newtons. All right. Then our mass A, we know that TEA is equal to mg. So we make m subject to the formula, which gives us mass A. Therefore, mass A is going to be equal to TEA divided by G, which is equal to 196.2 divided by 9.81, which gives us a 20 kg. So this is finally the mass of cylinder A, which will maintain equilibrium. I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.